Hello everyone. As an application of ordinary differential equations, first order linear, here we discuss the law of natural growth and the law of natural decay and natural growth. Okay. Coming to the law of natural decay, the rate of decay of a radioactive substance is proportional to the existing mass. Let y be the existing mass. Okay, then the rate of radioactive substance, the rate is dy by dt is proportional to y. So this implies here, if I multiply a constant of proportionality here, dy by dt is minus of k into y. So here I multiply minus sign here, minus of k, because we are talking about the decay, right? Now if I solve it, here dy is equal to dy by y is equal to minus k dt. If you integrate both sides, here ln y is equal to minus kt plus some ln c. Okay, so now bring this to this side. So that means ln y by c is minus kt. If we remove this ln, taking exponential to both sides, implies y by c is equal to e to the power minus kt. So this implies what is your y? Your y is equal to c e to the power minus kt. So after simplification we will get it. Okay. So here this minus sign indicates, what is the meaning of this minus sign? The amount decreases within time, right? Amount decreases with increase in time. Right? Likewise, coming to the law of natural growth. Okay, the total amount present is y. So dy by dt, likewise it is proportional to y, but this here you have the constant of proportionality is positive. Dy is equal to ky. Okay, here this sign you see here it is plus k, because here we are talking about the growth here. And likewise, if we simplify it, here dy by y is equal to k dt, and if you integrate it, likewise you will be getting y is equal to c e to the power kt. Okay, so this is the law of natural growth and law of natural decay. Okay, so let us now solve various problems to make aware of you these applications. So before coming to some important examples, let me to introduce myself. Myself, Professor Susanta Kumar Paikray, currently working as a Professor of Mathematics at Veer Surendra University of Technology, Burla, Sambalpur, Odisha, India. Okay, so without much delay, let us now discuss some varieties of examples to make you aware of such applications. So coming to an example, the half-life of uranium. The half-life of uranium is 1000 years. Find the percentage of the original amount that will remain after 3000 years. Okay. Means here y of 3000 will be what? Also find how many years only 1/10 of the original amount will remain present. So find the how many years only 1/10 of the original amount will present. Means the original amount, I can say the original amount is my initial amount, y of 0. Okay, so y of what will be 1/10 of the amount, means 1/10 y0, right? The original amount here is y0. Original amount here is y0. Okay, so let me to solve this problem. let y be the amount of uranium at any time t. Now it is a case of radioactive decay. We have, by law of natural decay, dy by dt is proportional to your y amount present. So that means dy is, since we are talking about the decay, is here minus of ky. Okay, so that means dy by y is minus k dt, integrating both sides. So that means here log y is minus kt plus ln c. So that means here y is equal to c e to the power minus kt. Okay, so according to the law we have this. Now coming to the conditions, you see the conditions carefully. Now in view of the conditions, let y0 be the original amount, be the initial amount, original amount at time t is equal to 0. Okay, so that means here y of 0, right, is y0. This is one condition. Another condition is half-life of uranium is 1000 years. Means again y of 1000, okay, is half-life, means y0 by 2. This is another condition. So you see here we have two constants. One is the arbitrary constant c, another is the constant k. To find these two constants we need two conditions, right? We need two conditions. So let us impose the conditions. Let it be my equation number 1. Okay, so impose this condition on 1. So what we are asked exactly? What we are asked? We are asked to find after y of 3000 is what? It is asked. And also we are asked y of at what time it reduced to 1/10, means y0 by 10. These two things are asked. Okay, so now we solve it to find the value of c and k. Then we think of I and 2i. So let it be my condition I, let it be my condition 2i. Using I in equation 1, we get here y0 is equal to c e to the power 0. Means here c is equal to y0, right? Then using condition 2i in equation 1, we get t is 1000, y is y0 by 2. We get y0 by 2 is c e to the power minus 1000 k. Okay, and we substitute the value of y0. So this implies here y0 by 2 is equal to value of c is y0, y0 e to the power minus 1000 k. Now y0 cancel in both sides. So that means half is equal to e to the power minus 1000 k. So we should find the value of k, or we should find the value of e to the power minus k. So what is e to the power minus k? Now it will be half power of 1 by 1000. Okay, because I can write it e to the power minus k whole to the power 1000. In that way, right? So this is the value of e to the power minus k, or I find the value of k. Then coming to 1, you are asked y of 3000 is what? right? So we are interested in finding this. Okay, so before that, let me to see now what is this equation 1 now. With this value of y0, I have the value of c and the value of k. So this implies, so therefore what is your y? Y is equal to y0 half to the power t by 1000. T by 1000, okay? So this is my y now. Because I substitute this e to the power minus k and I substitute this c. Okay, I substitute this and this to get it. So this is my equation number 2. This is my equation number 2. Now I use this. So y of 3000 means t is 3000 is equal to y0 into half 3000 by 1000. So this is equal to y0 divided by 8. Okay, so that means here 12.5% of y0. Thus 12.5% of original amount will remain after 3000 years. Now coming to 2i. It is asked y of what is y0 by 10. Okay, so let us use this on equation 2. Equation 2 gives your y0 by 10 is equal to y0 into half t to the power t by 1000. So we simplify to get the value of t. So y0 cancelled on both sides. So my half to the power t by 1000 will be 1 by 10. So that means your t by taking ln half is ln 1 by 10. So that means t by 1000. It is minus log 2. Minus ln 2 is minus ln 10 because ln 1 is 0. Ln 1 is 0. So that means here t is equal to 1 by ln 2 into 1000. Okay, because ln 10 is again 1. So if you simplify it, it will give you 3321.928. So this is approximately 3322 years. Okay, 3322 years. Thus after 3322 years, only 1/10 of original amount will present. Now coming to another example. So now coming to the solution. In a culture of bacteria, the rate of increase here, growth, is proportional to the number present. Right? If the number doubles in every 4 hours, suppose the original amount is y0. So it doubles in 4 hours. Means y of 4 is 2 times the original amount. y0 is the original amount. Right? And how many will be after 16 hours? Y of 16 will be what? Here y0 is the original amount. Okay. So now here the radioactive growth. Let yt be the amount of bacteria at any time t. Let y0 be the number present initially. What does it mean? Means here y of 0 is y0. So this is a condition 1. Right? This is a condition 1. So what more conditions are there? Now by law of natural growth, we have by law of natural growth dy by dt is proportional to y. So that means dy is equal to k dt, dy by dt, dy by y is k dt. So this implies here ln y is kt plus ln c. So that means y is equal to c e to the power kt. Okay, so let it be my equation 1. Now condition 1 is this. What more conditions are there? Another condition here is y of 4. Right? We have the initial conditions. We have the conditions. We have the conditions. Okay. We have the given conditions. Y of 0 is equal to y0 and y of 4 is equal to twice y0. So let it be my condition 1. Let it be my condition 2. What is asked? You are asked to find y of 16 is equal to what? So this is being asked. Okay. So now imposing condition 1 and 2, using condition 1 I in equation 1, we get, so when time 0, y is y0, so y0 is equal to c, so this is c. So therefore, so this again using condition 2i in equation 1. Condition 2i means when y is 2y0 implies it is e to the power 4k, and the value of c I substitute here, it is my y0, right? It is my y0. So if I simplified, so y0 cancel both sides, e to the power 4k is equal to here 2. So that means my e to the power k is 2 to the power 1 by 4. So this is the value of e to the power k. Now substituting c and e to the power k, our solution 1 follows. Now 1 follows y is equal to y0 e to the power k means this 2 to the power 1 by 4 t. Okay. So this is my equation number 2. Here means we substitute the value of e to the power k and substitute the value of c. Instead of e to the power k, we may substitute only k. No issue. So now when t is equal to 16, we have to find after 16 hours. Here y is equal to y0 e to the power 2 to the power 1 by 4 into 16. So actually it is e to the power kt, means what does it mean? It is e to the power kt, means whole to the power t. Okay, e to the power k t, right? Means it is here y0 e to the power, it is y0 2 to the power 1 by 4, 2 to the power 1 by 4 whole to the power t. Means it is here y0 2 to the power t by 4. Okay, so that means this is my equation number 1. This is my equation number 2. Right? This is actually here equation number 2. Because we have obtained the value of e to the power k. This is your equation number 2. Okay, now we substitute it. So we substitute the value of t as 16. It is 2 to the power 16 by 4. This is equal to y0 into 2 to the power 4. So this is equal to 16y0. 16y0. So that means after 16 hours, y of t is equal to 16 is 16y0. So what does it mean? Hence after 16 hours, after 16 hours, the number of bacteria will be 16 times the initial amount, will be 16 times the initial amount. 16 times of the initial amount. Okay. Now coming to one more example. The solution here. The rate at which the population of a city increases, means rate of growth, is proportional to the population of the city. Right. So it is law of natural growth. So there are 1,10,300 people in 1930. So if 1930, if I take it initial, as if I shift it initial as 0. Okay, means I can write it y of 0. Y of 0 is my this 1,10,300. Means my y of 1930 is converted to make the calculation easier. Okay, so if 1930 is 0, then 1960 will be my 30. It will be my 30. So this is my y of 30 will be this much. Okay, so we get two conditions here. Then we are asked, then this will be what? It will be 40. So y of 40 will be what? Okay, so let yt be the population of the city, be the population of the city at any time t. At any time t. We have by law of natural growth dy by dt is proportional to y. So that means dy by y is equal to k dt, and so that means here dy is equal to, implies here y is equal to c e to the power, directly you may write also y is equal to c e to the power kt. Okay, so now coming to the, let it be my equation 1. We have the initial conditions. We have the initial conditions. Here we setting 1930 as 0. Right. So we have y of 0 is 1,10,300. 1,10,300. Then y of year 1960 becomes 30. Y of 30 is equal to 1,50,000. And you are asked y of 40 will be what? Okay. So let it be my condition 1. Let it be my condition 2. So likewise we impose condition 1 and I and 2i on 1. So now using condition 1 on I on 1, we have e to the power 0 is 1. So c is this. Now using condition 2i on 1, we have 1,50,000 is equal to 1,10,000. Let this amount in the question be 10,000. 1,10,000 for easy calculation. So it will be 1,10,000 e to the power 30k. So that means e to the power 30k is 15 by 11. Implies here e to the power k is 15 by 11 to the power 1 by 30. So at here t is equal to, at t is equal to 40, what will be your y? Y is equal to 1,30,000 into 15 by 11 to the power here 40 by 30. So this is equal to 1,30,000 into 15 by 11 to the power 4 by 3. So this is your answer. Okay. So this is your answer. So coming to the summary, in the law of natural decay we have the proportionality constant is negative, and in growth proportionality constant is positive. Accordingly we have solved 3 examples here. You should solve some more examples or questions from any standard book. Okay. So at this stage my appeal to all of you is that if you find this lecture is helpful and interesting for you, please like and subscribe to this channel, and this will boost my motivation to upload subsequent lectures for your benefits. In my upcoming lecture I shall discuss the electric circuit. Okay, electric circuit, RL circuit, RC circuit, etc. RC circuit, etc. Okay. So the video is getting lengthy. We should close it here. Thank you all. Thank you all. Have a nice day. Let us close this lecture.